For the second part of your lesson, we're using the same note taker as before too. Now we're going to be doing the opposite situation. Now you're going to be given a very large number, and then you're going to practice writing it in scientific notation. So your first step is to move the decimal point to the right of the first non-digit 0. Count that number of places you've moved the decimal point, and this determines the exponent on 10. And remember, for something to be properly written in scientific notation, your factor has to be between a number between 1 and 10, and you have to have times 10 to some power, okay? So if you have a really small number to start with, okay, you're going to end up with a negative exponent on 10. If you have a really big number, you're going to have a positive exponent on 10. All right, so let's practice doing this right now. So if we're writing this number in scientific notation for question number 1, we've got 50,000, okay? So the first step is to put your pencil in between the first non-zero digit that's between 1 and 10. So I see there's a 5 here, so I'm going to put my pencil here. I'm going to count from the end, okay, so right here, I'm going to count how many places it's going to take me to get from this place to that place, okay, and I'm going to do that with my smiley face again. Okay, so here I go. Starting here, 1, 2, 3, it takes me 4 places to get my decimal point in between the 5 and the 0. So to write this properly in scientific notation, I'm going to make sure that that first number is a number that's between 1 and 10. So, and get rid of all the zeros, because that's the whole point of scientific notation, is to get rid of all your zeros. So, shorthand way of writing this. You can either leave this as a factor of 5, or you can make it 5.0. We still have that factor that's between 1 and 10. We're going to write times 10, and we always will for every single problem. Now remember, if you have a large number, we're going to have a positive exponent on 10. We moved 1, 2, 3, 4 places, so my power on 10 is going to be to a positive 4. I can check my answer for this one using my calculator. So 5 times 10 to the 4th power would give me 50,000. All right, so if I look at the next problem, my decimal point starts here at the end. I want to get the decimal point to be in between the 2 and the 5, because this is my first non-zero digit. And then I don't want to write any of these extra zeros in here, okay? So I'm going to grab my smiley face, and I'm going to count how many places it takes me to get from the ending decimal point to the one that's in between the 2 and the 5. So 1, 2, 3, 4, 5, 6, 7 places to get there. So I'm going to write down the first part, which is the 2.5, and get rid of all the extra zeros. I have a factor that's between 1 and 10. I have times 10, since it's a positive number, since it's a large number, I'm going to be moving it 1, 2, 3, 4, 5, 6, 7 places, we said, so it's a positive 7. All right, to problem number 5, and I realize I'm not doing the bottom problems right now, so let's just go across. Okay, I start here at the end. I want my decimal in between the first 2 numbers. You can see there's no zeros in this problem, so this problem really doesn't need to be written in scientific notation because it's not that big. But just to practice it, I'd be moving 1, 2 places to get there. So to write the final answer, 6.83, we have to include the 3, because if I were to punch this into my calculator, I'm going to get the same result back. So 5.83 times 10, since I have a large number, I'm going to have a positive exponent, and I moved it 1, 2 places. So 6.83 times 10 to the second. Now, for problem 7, problem 2, problem 4, and problem 6, you can see that these are dealing with tiny numbers, right? Little tiny numbers, decimals. So the process is the same, except whenever we move our decimal point, we're going to be forgetting the zeros in front and putting our decimal point in between the first 2 real numbers other than 0, okay? So when I do this, I'm going to count, and I'm going to grab the smiley face, how many places it's going to take me to get from the decimal point to where I placed it. So 1, 2, 3, 4, 5, 6, 7 places to get to that red line. So how I write this, remember, is your factor has to be between 1 and 10, so I'm getting rid of all those extra zeros, so 3.3 is between 1 and 10. You always write times 10, and then we said we moved 7 places, but since we're dealing with a tiny decimal, and we moved our smiley face decimal to the right, we're going to be including a negative exponent this time. So it's 3.3 times 10 to the negative 7. In problem number 4, this 0.000506, you want to get that decimal point in between the 5 and the 0. So I'm going to grab the smiley face, start at the decimal point that I see, and go 1, 2, 3, 4 places to get it there. So when I'm writing the answer, 5.06, you have to include the 0 because it's serving as a placeholder for the 6. We're getting rid of all of those extra zeros that are in the front though. So 5.06 times 10, now we have a small decimal, so we're going to have a negative exponent plus we moved it to the right, and we moved it 1, 2, 3, 4 places, so it's 5.06 times 10 to the negative 4. Okay, for problem number 6, you want to end up with a decimal point in between the 4 and the 5. In question number 7, you want to end your decimal point after the 5 because you want to have a number between 1 and 10. And for problem number 8, in between the 2 and the 4. So I'm going to pause the video and I want to see what you guys can come up with. I'd like you to pause the video also and try out these 3 on your own. Okay, hopefully you've had enough of a chance to get those 3 problems taken care of. For problem number 6, the correct answer would be 4.5 times 10 to the negative 6 because again, you want that decimal point in between the 4 and the 5. So I've moved it 1, 2, 3, 4, 5, 6 places. Again, since I'm dealing with a tiny decimal and I moved it to the right, it's negative 6. For problem number 7, we wanted to move the decimal point behind the 5, so we get that factor. It's between 1 and 10. 1, 2, 3 places, and again, because I moved to the right, I'm dealing with a tiny decimal, negative exponent. And then for number 8, opposite situation, your decimal point's actually here, and we're moving it to the left. We're dealing with a large number. So this would be 2.45 times 10 to the positive 6, because I moved it 6 places to the left, and then that final answer would be 2.45 times 10 to the 6. The other thing you're going to be doing is you're going to be looking at some word problems to help you to answer these questions in scientific or standard notation. It says here an album sold 8,780,000 copies. How many more copies does it need to sell to receive the award? Well, it says here it receives the award when it sells 10 million copies. So what you're going to do is you're going to first figure out how many more you need to get to this 10 million. So if you need a calculator, go grab one. So you guys can see when I used the calculator, when I subtracted those 2 numbers, I got this number on my calculator. But I can see that my answer choices are all written in scientific notation. So when I take a look at this, I want to make sure this decimal point is in between the 1 and the 2, but I have to count here at the end to the right of that 0. So 1, 2, 3, 4, 5, 6 places will do it and get that 1.2 in between the 1 and the 2, or the decimal point. Since we're dealing with a large number, the answer is not B, it's going to be C instead because we're dealing with a large number. For the second part, it says if an album sold 955,000 copies, how many more copies do you need to sell to receive the award? And then it says to write your answer in scientific notation. Okay, well, it's sort of the same process. We're going to start out with the 10 million. So 10, 1, 2, 3, 1, 2, 3. And then I'm going to take off this time only 955,000. Okay, when I take a look at that number that's remaining, I got to get this in scientific notation. So the first thing I'm going to do is I'm actually just going to write it. So 9045 and then 3 zeros. But remember, that is standard form. So I want to make sure that I get this 9,045,000 in scientific notation. So remember, I got to get my decimal point in between the 9 and the 0. But I have to include the 4 and the 5 because I want to make sure if I were to type this in my calculator, I'd get the same thing back. So 9.045 times 10, well, if I start my decimal point here and count 1, 2, 3, 4, 5, 6 places. I'm going to have a positive exponent since I'm dealing with a large number. So 9.045 times 10 to the 6th power. Additionally, you can use those tricks that we've learned before to help you to order these numbers in scientific notation from largest to smallest. We know that the larger exponent that we have on 10 is going to tell you whenever you have a number that is much bigger. So this is talking about geological eras. So we have the Paleozoic, the Cenozoic, and the Mesozoic eras. This happened a really long time ago, right? Because this has the highest power on 10, this 5.42 times 10 to the 8th. In the question, it says order the eras from the earliest to the most recent. So when we talk about the earliest, it would be which one occurred the longest time ago. Well, it's either between the Paleozoic or the Mesozoic because we have the same power on 10. So these are really big numbers, right? Happened a really long time ago. The larger one is actually the Paleozoic because the factor in front is 5.42 compared to the 2.541. So the Paleozoic would be the earliest, then the Mesozoic, and then the Cenozoic. Okay, it said here, if the T-Rex lived 7.10 to the 7th years ago, what era did it live in? Well, if I look at the powers on 10, chances are it's going to be the Cenozoic, right? Because it has the same power on 10. So the Cenozoic. Okay, we're going to use that trick to help us to order some of these examples. So I'm going to try out one or two with you, and then I'm going to have you guys try out the rest on your own. So in the first one, we have 5.76 times 10 to the 12th, 9.66 times 10 to the 11th, and 5.7 times 10 to the 10th. If you notice, they all have different powers on 10. So we have 10 to the 10th, 10 to the 11th, and 10 to the 12th. 10 to the 12th is the biggest, right? Okay. So that means the smallest is going to be the 5.7 times 10 to the 10th. The second largest would be the 9.66 times 10 to the 11th. And then finally, this times 10 to the 12th. All right, we're going to use the same trick here. We're looking at these. Now, remember with negative exponents, you actually got bigger the negative exponent, the smaller the number, okay? And if I take a look, I've got two numbers here. I've got the 9.9 and I've got the 7.6 that have that same times 10 to the negative 15. If I'm thinking about which one is actually going to be the smallest, when you think about it, it's actually going to be this one, then followed by this, and then to the third. Okay. In number 3, one thing I'm noticing is every single one of these has the same power on 10. They're all 10 to the 8ths. So what I'm going to now look at is the factors. If I look at number 3, I can see it's 1.2, but I'm going to stick a 0 on there just so I have the same amount of place value positions as it does for 1.19 and 1.112. If I'm trying to figure out which one is the smallest, well, 1.12 is smaller than the other ones. So this is going to be our smallest, followed by the 1.19, and then finally the 1.20. That extra 0 helps us sometimes. All right, for 4 and 5, the first thing you guys want to do is you want to, I say, change them all to the same thing. So 6.3%, percent means per 100, so that means you'd be dividing by 100 to see what your decimal answer is. And I think it's easiest to actually just write everything as a decimal because then you're comparing the same thing. So I have 0.063. This one here, if I'm moving it 3 places, it's 0.0625. And then this would be 6.25 for 6 and a 4th. And then I have 0.625. So if that helps, you can help you out right now for question 4 and 5. Check back in a few to get the right answer. Okay, so if you're looking at your answers for question 4, the smallest would be 6.25 times 10 to the negative 3rd, followed by the 6.3%, and so on. It's very helpful to have the same place value positions. So when I was deciding between these two, I actually tacked on that extra 0 to help me out. Same deal with down here.